Okay, let's try that again. Hello. We're going to give it a couple of minutes. Let people filter in. Let the website catch up. Oh, excellent. Website's already caught up. It is on the ball today. Alright, and everything seems to be working correctly. Alrighty. Mention my stream here real fast. And here we go. All right. Everything's kind of in the same place it was last time. Did a little bit of fiddling around with some stuff. I'm assuming here that the whole setup should be the same, but you never know sometimes. So if anything's different or out of place or wrong, let me know. Alrighty, I think we're gonna get started here. So, last time, the end of the stream, went ahead and did a poll. Here, let me move this over so that way I could talk. So last time at the end of the stream, we went ahead and did a poll, and that poll was, what method should I use for this 3.3 volt issue? So if you remember correctly, last time, ran into a small issue at the very end where, you know, I had a couple of different options on how to proceed, and I decided to kind of put it up to a vote, see what people wanted to see. So, our issue was that this board here takes 3.3 volts to run. Now, when I say 3.3 volts, I mean the power here actually takes 3.3 volts. The rest of these pins also take 3.3 volts. However, they are 5 volt tolerant, so you can plug them into an Arduino directly and they'll work. So, my issue was that this particular Arduino only has two 5 volt outputs and no 3.3 volt outputs. So I had a couple of different ways to proceed. One of the options was to use this Arduino Leonardo, and this does have a 3.3 volt output, and the rest of these are 5 volts. and it runs on 6 to 12 volts. So instead of my buck converter here, which converts this 12 volt power supply down to 5 volts, I would convert it down to, well, I wouldn't even convert it. I would just plug this directly into the 12 volt power supply, because it can be supplied or powered with 12 volts. And then this would work. Another option that I suggested was to use this guy here, which is a Wi-Fi enabled board. And this is pretty much exactly the same pinout and setup as this. This is actually just an Arduino on here, except this has a wireless card on the top. So I can use this for wireless stuff later on if I wanted to. But basically I'd just be swapping in the boards, and I'd have to find another way of powering this. Which I think you can do, yeah, instead of the barrel plug, it would be like a wire directly into one of these pins, the VN, I think. So that was another option. Another option that I had was to use another buck converter, was to use another buck converter to convert the 12 volt power supply down to 3.3 volts. So I'd have two buck converters, one from 12 volts to 5 volts for the board, and then one from 12 volts to 3.3 volts for the reader. And then finally, my last option that I presented was using a Teensy 4.0, which is an entirely 3.3 volt board. And again, I kind of run into the same issue here where I don't actually have a barrel plug for this, so I need to swap this out for an actual, like a pin VN or something. So I'd have to convert this down, instead of to 5 volts, it would be converted down to 3.3 volts. And then this entire thing runs off 3.3 volts. The other issue with this is that since this is 3.3 volts, and this component here takes 5 volts, I would have to use what's called a level shifter to convert the logic from 3.3 volts to 5 volts for the data. So, put it up to a vote, and last time it was split 50-50 between using the Wi-Fi board, so this guy, and using this Teensy 4.0. So, the easier of the two would probably be the Wi-Fi board, because this is basically just a straight swap. I'm essentially, all I'm doing is just swapping out these pins and then finding a way to power this, and then that's it. Don't even have to change the power supply or anything. And then this is the more interesting of the two. So this will actually make for maybe a longer stream, or even several streams. But it's more fun, and you learn more. But I think what I want to do is I want to keep this at maybe just a couple streams and an hour long. This stream, about an hour long. And probably take the easy route, power this guy using one of these pins, one of these outputs, and just kind of stick with that, and then, you know, connect this up to the board. I don't know. I don't know if I have a use for the Wi-Fi yet, aside from maybe later on connecting this to a service or a database or something and pulling credentials from the database into here instead of hard coding them. But I want to keep this simple, and I don't want to involve a bunch of Wi-Fi. Well, I suppose we could use that. This is our level shifter board, and so this, if I open it here, nice clean tear, it says. So this is the level shifting board. This will take 3.3 volt logic and 5 volt logic and convert between the two. So we have the the VA down here and the VB up here. And these, the VA is your low-level logic, and then the VB, these B pins up here are your high-level logic. So this would be your 3.3 volt side, and this will be your 5 volt side. A couple of things that we have to do with this in order to get it to work, but it's fairly simple. So what I think I want to do is try and find a way to power these, which I think I already have. Perfect. I have this that I created earlier. This is literally just a barrel connector or a barrel plug for this guy. It just plugs right in. You have your positive and your negative. Easy enough. So what I can do is connect this guy up to, let's say here, one of these. I have a bunch of cables in here. Ooh. He says, almost knocking his stuff all on the ground again for the upteenth time. Bunch of cables in here that should work. Here's a black I can just plug in right there. So this will be a female to female. There we go. Plug it into one of those. Or one of these. And there should be a red, or an orange at least. I suppose an orange will work. Keep with the theme. If there ever was a theme. And plug it in like that. And there we go. So I think I finally decided on what I want to do. And we will go with the level shifting route, I think. As my little AT-Tiny85 board here. I think we'll play with this at some point, but not today. It's another project for another day. And so we'll have to deal with the level shifting in a bit. But for now, what we can do is we can... we have to do a couple of things. We need to take this buck converter and convert our logic back down, or our voltage back down from 12 volts to 3.3 volts instead of 12 volts to 5 volts, because otherwise I will blow up that little teensy and it will be very sad. Because those teensies are not cheap, and I would prefer not to blow one up. Hook up our multimeter here. Try and have to get our magnet in the way of everything. And let me double check a thing. Let's see here. Okay. Alright. So we get our multimeter out. Let's see if I can get it in frame anywhere. That may not happen, but I can try. Oh, he says. Okay, the challenge isn't getting it in frame. The challenge is getting it in frame and also the buck converter, so that way I can, you know, mess with it. And we will take our trusty screwdriver, make sure that this fits. Excellent. Okay. Let's see what voltage is coming off this thing. Should be 5 volts, just about. 5.036 volts. So we're gonna take our screwdriver and twist this until it goes higher or lower. Whoop. Or, you know, until, you know, this disconnects. There we go. Okay, hang on. I don't have this connected quite properly. Keeps reading 0 volts. It's because this guy is loose. There we go. Alright, we'll try that again. So now we take our screwdriver, and as I mentioned in the last stream, you basically just screw this in one way or the other. That is going up, so this should be going down. Yep. So we're gonna put this down to 3.3 volts. 4, 6, 5. 3.7, 5, 4, and 3.3. Okay, that's just about 3.3 volts. It can be just a little bit above 3.3 volts. A lot of these have tolerances to them. So if it's just above 3.3 volts, that's also fine. The tolerance for the input, I took a look at the data sheet for these guys. The tolerance for the voltage in on this is anywhere from 3.3 to 3.2 to 3.6 volts. So 3.32 is just in that range. And so now I have to take a look at the pin out diagram and find out where the V in is on this thing. Okay, so looking at this from this angle, oh, I'll be damned. This actually takes, for the input, it's 3.6 to 5.5 volts. I was looking at the teensy 3 point something rather than the 4.0. So the 4.0 actually can take 5 volts and prefers to take 5 volts. So we're gonna have to readjust the the buck converter. But I did find the V in pin. That's a good start. Remember, kids, read your data sheets carefully. If you don't, you might explode your stuff. Alright, so I'm gonna readjust the voltage to go from 3.3 to 5 volts once again. I'm going to try and do that while not killing anything. Alright, hang on a moment, let's see. There we go. Just about at 5 volts. say 5.026 is probably close enough. I would like to just overvolt my stuff. And the reason for that is when you start hooking things up, the voltage doesn't really drop. It's the current that drops. But the voltage actually does drop just a hair when you start plugging a lot of stuff in, or when it starts sucking up a lot of current. So you want it to be just above rather than just under your target. That way you can ensure that you have the correct voltage going to your thing no matter what. Okay. So, we should have... Alright, if we're looking at this teensy like this, then our VN is right here, this far pin. And looking at the datasheet, it says 3.6 to 5.5 volts. And then this right here, right next to it, is the ground. That's easy enough. And so now all I have to do is plug it into our power supply, into our buck converter specifically, and hope it doesn't explode. Well, that's a good sign. It didn't explode, so there's no light or anything, I don't think. No, there's no LED, so we don't know whether or not it's actually on, but it should, in theory, be running. I just don't know what it's actually running. I'm going to have to get a micro USB cable in order to connect that, which I do have. Okay, so power issue solved. We do have power going to the Steensy. And now we have to, let's see, the other part of this was hooking up this right here. So let's go ahead and hook up the RFID controller. So I do have a wiring guide up on my screen for it, somewhere. There we go. Alright. So as far as wires go, I'm going to need female to female. So I'll have my wires right here. And my wiring is as follows. One, I need to supply... just make sure that's off. One, I need to supply power line. So that goes from the far right, the 3.3 volt, as it's labeled there. I don't know if you can see that, but this pin is actually labeled 3.3 or 3V3. And that goes to this pin right here, which is also labeled 3.3 volts. That's actually a 3.3 volt output. So that should give power to our RFID reader. And then ground, which, let's see if I can find a black cable in here. I found a gray one. I think it's close enough. Alright, and on the other side of this, nope, not quite the other side, it's actually right here is our ground. And then this one will connect to one of the pins. He says, looking up the wiring guide again. Looks like there is a ground on the other side of this right here. Okay, so that's our ground. Excellent. And let's see if this thing actually gets power. So if I exploded the little 3.3 volt teensy there, then we'll know. Well, looks like I am actually getting power to that RFID reader. Excellent. That works. It's exactly what I wanted to see. Alright. So now we wire up the rest of it. Ready. Let's see. What is this one? This one is the reset pin. And this can kind of connect to anything. It says digital 9, but I'm just double checking here, making sure everything's correct. So I gotta kind of translate between the digital pins on the Arduino and then this guy, because this guy is a slightly different pinout. There is a digital 9 pin right here. And so that will be our reset pin. We'll give him the color white. For why not? There we go. And we'll connect it up to the digital 9, although it doesn't actually matter which pin you connect it to. I'm going to, for sanity's sake, connect it to 9. Ready? Our next one is not the interrupt request, the IRQ right there, that pin, we are not going to be using. That's the interrupt request pin. So that's if I decide I want to program this using interrupts, which I do not actually. I'll be using a polling method instead. I'll be constantly polling this, querying it for information. Another way to hook these up is to use what's called an interrupt request, which will basically, when this gets information, this will send it through this pin. Well, it'll send a signal down this pin, and then I'll be able to capture an interrupt request on here. And then, no matter what this code is doing, it'll interrupt it and say, hey, there's some data that you need to get. But in this case, I'm setting it up so that way I have to poll this for information. I have to constantly ask it, is there information? Is there information? Is there information? Are you ready? Are you ready? Are you ready? Rather than the other way around. The other way around is more efficient, yes. But we're going to take the easy route and just say, you know, constantly poll it for now. So we're going to do the MOSI and MISO, which is the, as I mentioned last stream, that's the master out slave in and master in slave out. And we'll connect those. And so MOSI goes to MOSI and MISO goes to MISO. Easy enough. Just need to grab the pinout diagram for this guy again. There it is. So on this, looks like our MOSI and MISO pins are these two right here on the very end. This one and this one. And so MOSI is this one and MISO is this one. And we'll give them the colors blue and purple, I think. Looks like that's what's happening. All right. He says putting a green one down. Okay, so it looks like our MOSI is blue and our MISO is purple. And so all I have to do is connect them in the same sequence on this side. Our MOSI is blue and our MISO is purple. Right there. Alright. Now I need to connect the SCK or the clock line. And again, looking at the wiring guide. Okay, looks like pin 13. Yeah, 11, 12, and 13, yeah. Okay, so 13 is on the other side here, and that's our SCK or our clock line. And that one will be green, because I have green. Okay, and finally our SDA or our data line. And that one will be digital 10, which should match up on here. CS. Okay. SDA CS chip select. Maybe that isn't a data line. Maybe that is the chip select line. Because that would make sense now that I actually read the CS on it. I always figured that was a data line. But it could be that the data is going through the MOSI and the MISO instead. Okay, and then that goes into pin 10, which is this final empty pin right here. And so this should, as soon as I get this actually hooked in, should be all hooked up. Okay. Just make sure that actually powers on still and doesn't explode. Alright, looks like it powers on and it doesn't explode, so that's a good start. And there we go. Alright, so what I want to do now is take this and somehow feed it into these three. So I'm going to need 5 volts, ground, and data. So this is the thing that we did yesterday, which was connect these three into this Arduino here. And I fed it 5 volts, a ground, and then this was our data line. This didn't actually matter which pin it was connected to. But now I need to do the same thing, except with this teensy. And unfortunately, since this is 5 volts and ground, and this data line, or this high-low essentially, I call it data line, but really it's just a primitive high-low. This is all 5 volts. So our issue is that we have to translate 3.3 volts to 5 volts. Well, we have two issues actually. One of them is that we have to translate 3.3 volts to 5 volts. The other is that I don't have a 5 volt output on this board, I don't think. Let me double check the pins, but I don't believe I have a 5 volt output on the board. Yeah, I'm not seeing 5 volts out. Okay, so two problems. One, we need to power this with 5 volts. Two, we need to connect this to our logic board at 5 volts. Now, the interesting thing about this is that we could actually connect this directly to the board and have this give out a high-low signal. And then this would actually send out 3.3 volts on high and 0 volts on low, which would technically register as high on this side. The problem is if I don't translate it to 5 volts, then there's a really good chance, because 3.3 volts is just barely at that kind of high, you know, registering or reading as high at a 5 volt line. There's a good chance that any transients or any noise on the line or anything that happens will pull this high or low, or will pull it low from high. So it might be a little bit fritzy if I do it that way. So yes, the solution is to take this board and connect it up and basically translate our 3.3 volt signal in here to a 5 volt signal up here. This board is way overkill for that, by the way, but this board is actually made for PWM signals, and yeah, it's way overkill for this, but I mean, that's what I got, so we're gonna use it. First things first, I gotta solder this together. I gotta put these pin headers on here. I could use female pin headers, but it came with male pin headers, and honestly, I don't really see a reason to use female pin headers. I don't have any, whatever, it doesn't matter to me. So I'm going to clear all of this off real fast and get my soldering station up and running, so that way I can solder those pin headers on. Very, very carefully get this off my desk. Alrighty. So we're going to do a little bit of through-hole soldering, which is a lot easier than the SMB soldering I was doing earlier. There we go. I can reach around here and turn this on. There we go. Trying to light my books on fire as I do so. Give it a little bit of flux. Set this guy down. And get myself a little bit of solder. And this looks fine for this, I think. That'll work. And where's my helping hands at? There they are. Perfect. Just kind of hold these together. It smells lovely. Try and flux up the board here and screwing it up already. There we go. Hopefully you can see this. Looks like you can. So we'll go ahead and flux up the backside. Just make sure it's got plenty of flux on it. And then those pins. It's a little overkill. Alright. Point is that we have flux on the backside of this. That's what we want. Alright. Try and do this in front of the camera here. It's kind of difficult to do it this way, but I think I can make it work. Is this my really thin tip? It is. Whoops. I have to switch tips. That's okay. It'll work for this. Okay. That looks all right. Go to the other side. All right. Little shaky hand there, but getting a little bit nervous. People judging my technique. Okay. A little hot, but that should be it. See if I can, there we go. It's not bad for the first row. Now we do the second row. So same thing, lots of flux. Alrighty. And put them on here like this. He says, there we go. Alrighty. One more time.
It's YouTube Music. Download the app today and get a trial of Music Premium.
Very confused.
Restrictions apply.
That ad shouldn't be running, because I do actually have YouTube Premium. YouTube's like, you're gonna get an ad anyway. Okay. Thanks, YouTube. Oh, I don't know if you see that, but that is not a good joint. There we go, much better. Not have the heat required for that one. Which is strange, because this is up to 750 degrees Fahrenheit, not Celsius. There's a lot of solder for that one. There we go. It's not perfect, but that's pretty damn good, actually. Let's see. Touch-ups here and there. Just don't actually do anything except make it look pretty. But I like my solder joints to look pretty. There we go. And it's relatively straight. Alright, let me go ahead and clean this up. Cleaning brush. little bit of isopropyl. Oops. Knock the camera down. Sorry about that. Alright.
You guys are staying at home.
Yeah, I don't know what's with these ads. It's very strange. I actually pay for YouTube Premium.
Take care of yourselves.
And still somehow getting ads. I did, yeah. That's very strange. I don't know. I'm not getting ads in my regular YouTube. I should be. You know, that could be it. I'm not sure. I'll have to double check that later. Either way, this is good to go. Perfect. Alright. So here's our level shifter. And we have our, again, our A side here and our B side here. Oh, let me go ahead and shut this off. And I'll swap out that tip later unless I decide to do some more SMB soldering. Don't want to damage my really nice thin tip. Put these away. Alrighty. So we'll go ahead and bring our stuff back. Very carefully bring our stuff back. Try not to drop too much, but drop a bunch of things anyway. There we go. Alright, untangle this mess a little bit. The problem with having longer wires is that they do tend to tangle quite easily. So if you have projects, I recommend recommend not dropping everything. I recommend once you're done prototyping, as we will do later, cutting your wires to the appropriate lengths that they need to be, because otherwise it's a nightmare to cable manage. Alright. Now we got the level shifter done, so we will hook it into our 3.3 volt supply here. Now here's an interesting problem. I have to somehow supply this with 3.3 volts and this with 5 volts, and I have no more pins available to me. That is interesting. How do I do this? Running into more issues as I think about this, but figure it out. I think the Wi-Fi board here probably would have been a lot easier, just because there's already a 3.3 volt pin on there that I could just use instead. Everything else is 5 volt tolerant. But where's the fun in that? Maybe we'll have to have another stream that finishes this project, but you know, I'll be damned if this is gonna beat me. So how do we get another 3.3 volt out? Is there another pin on the Teensy? Let's see. So the Teensy has one 3.3 volt out, and that is this pin right here. So we're already using that 3.3 volt pin to power this RFID reader. Okay. Huh. I'm not seeing another 3.3 volt. Yeah, it looks like this is the only 3.3 volt pin. So somehow I'm gonna have to split this pin. I mean, I can do that. I can take this pin and actually split it and get 3.3 volt power to this board here. We can actually do that with a prototyping board, in fact, which might be easier than wiring everything directly. Let me pull one out real fast without dropping everything. Something like that, I think. We can also use the 3.3 volt output of this board here, which could work. If I remember correctly, this actually can take up to 12 volts, but we're going to feed it 5. And this board here is actually a power board. It's a board used for powering, or using the power rails of the of your breadboards. So you basically just hook this into a breadboard, and then you'll have 5.5 volts or 5 volts or 3.3 volts, depending on which jumper position you have set. On this one I have 5 volts, and then on this side I have 3.3 volts. Or if I set it over here, I can set both rails to 5 volts. Right here I have a smoothing capacitor. It's just a 10 nanofarad, no, 10 microfarad capacitor. Sorry, not nano. So we can use this and cheat a little bit. It'll be easier to hook up. So let me go ahead and take this stuff. Undo some of this and move this to, let's say, this will be the 3.3 volt side. We'll call this the 3.3 volt side. So I'll go ahead and just connect it right here. He says. We'll try to connect it right here. There we go. Got it in there. And we will connect our teensy up. Make things a little easier on us.
Does more than catch errors.
Again, the ads. Sorry about that. It's very strange. Alright, so our teensy we can kind of connect whatever way we want as long as the pins fit. They do. So we're gonna, except for that back. It's gonna prevent me from actually connecting this directly to the board, so I'll have to do a female to male pin connectors, which I do have somewhere. There we go. This guy has 5 volts. That should power everything, assuming it doesn't explode. Let's just make sure it doesn't explode. In a moment. Alright, please don't blow up. Didn't blow up so far. Nope, still didn't blow up. Excellent. Good. Now, thankfully, with these boards here, I've read reviews on these power boards that say maybe there's some noise issues on them. I haven't actually. I put the smoothing capacitor in here, but I didn't need to. It seems like this capacitor does a fine job of smoothing out the noise. And if you don't want to use these rails, you can actually just connect the stuff directly into these pins here, which I might do. I don't know. We'll figure it out. Either way, we've got power to it. That's all I need.
The reviews are in. We asked and you answered.
Suddenly I'm getting ads like every video.
Different kind of PBS.
I swear I paid for YouTube. It just doesn't think I did. Sorry about that. So what I'm thinking is, yeah. So I'm going to take these wires now. And so here's our beefcake relay. And I'm going to connect the power and ground on the 5-volt signal line. So here's our ground. Let's do a little bit further up so it's easier. There we go. There's our 5-volt ground and our 5-volt power. And our signal. So if we connect the signal to, let's see, this should be 5 volts. Okay, so that's ground, that's 5 volts. So right now this signal wire is going to be kind of floating, which might cause some issues, but hey, who knows? Maybe it won't. We'll set this aside here so that way you can kind of see what we're aiming for. Whoops. As he crosses a bunch of power lines together, it's fine. It's not going to cause any noise issues now. So this is now kind of floating, but if I connect this to 5 volts, it will do nothing. Nope, 5 volts or ground does nothing. Huh, that's interesting. What did I do wrong? Oh, there's no power. That's what I did wrong. Okay, so 5 volts. Yep, there we go. If I connect this to 5 volts, you can see that the light lights up. And connecting it to ground, I mean it's floating still, but it should be off mostly. Yeah, looks good. Okay. Alright, so now what I'm going to do is connect this to some random pin on our Teensy, which I will figure out in a moment. So our VA side, or A, is going to be our 3.3 volt side, and we'll just stick it over here essentially. And same with the VB, that'll be our 5 volt side. So now we have a 5 volt side and a 3.3 volt side that are kind of clearly labeled. Kind of. Okay, I'll try and push these in and then struggle to actually pull them out later. There we go. That's going to be a giant pain in the ass to pull out later, but you know, whatever. It'll be fine, probably. I'll get another one of these for reference, because they do have the silk screen on them. Because I can't read, I can't X-ray vision my way through the board to see the silk screen on the other side. So these are like this. So in theory, it should mean that if I do this correctly, there we go.
Kira and Zach are collaborating. And
Perfect.
using Grammarly along the way. In the past.
So this is our VB side, or 5 volt side, our VA side. Okay. So you can see our output enable, or OE here. So that'll actually enable the, when I pull it high, it will enable the chip. That'll enable the translation. And then if I, so this will be the VA, this is the V in essentially. This is ground, 5 volts in, ground, 3.3 volts in, output enable, which will be tied to the 3.3 volts in. Let me just double check the specs.
caring of a woman. Felt the loss of a fallen
Yep,
child
looks like it. Cool.
underneath the sun.
Oops.
On the day I woke, so soulless.
All right. It's connected. That's connected. Excellent. That's all connected. And so we are going to connect this to any random pin, I think, except for the pins on the outside. What I'm going to do is I'm going to connect it to one of the first pins, probably B1, so that'll be, looks like that's ground on the other side, so I'll connect this to B1, which will be this pin right here, if I'm reading the silk screen correctly. Yep, cool. And so our 5 volts will actually be, need a male to male now. So this is our 5 volt pin. And this will just be connected to 5 volts. Okay. And let's see. And then on the other side is the 5 volt ground, or just ground in general. Because in theory the ground should be common. In theory.
But it's not my place for me off a lesson.
So we'll grab another male to male. I'll give it the color gray, because gray is a beautiful color. And this will connect to that pin there, and that will be our ground for the 5 volt side. Perfect. Alright, and finally, we'll connect up our 3.3 volt in and our 3.3 volt output enable. And the output enable will just tie high. In theory, you're actually supposed to, the reason the output enable actually exists is because you're supposed to wait until the power stabilizes before you enable the translation between these two. But I'm just going to say, screw it. My power supply isn't that noisy, so I think it'll be fine. In fact, I'll even add another smoothing capacitor to the other side of this just to make sure it's not noisy at all. So let's, skip this ad, which again, I'm not sure why I have ads, but and let's grab a another 10 microfarad capacitor. Down here. Excellent. I have a few capacitors. I should see there's a 1 microfarad, 10 microfarad right here. So one of these guys. Perfect. Alright. Set that down for now. And let's clip the ends of this. So capacitors are polarized, if you didn't know. The shorter end is the negative and the longer end is the positive. Or if you've just clipped these, like I have, just now, and you end up with the same lengths, the negative end is the guy with the stripe there. There we go. Okay, got a little capacitor on this side, just to smooth out any transients that may be remaining in this power, although again, I really have not seen this power supply be any sort of unstable, so I don't know what those Amazon reviews were complaining about. Maybe they got an older version of the board or something. Alright, so we have our smoothing capacitor on here, and so now we're going to tie this guy high using a male-to-male cable. There we go. That'll be our VA, or our input, I believe. Yes, so that's our input, VA, or our power. And our output enable, again, we'll just tie high. And that is on the other side. And we will give it a different color than yellow because I'm using yellow already. Give it green. I think. Again, we'll just tie that high. I think that should be okay. And finally, we need a female to male. And that will give us our capabilities. So this guy here, we will choose any kind of random pin on him. Doesn't really matter, I suppose. I just ripped all the cables out of it, so that's good. And we'll use yellow. Find a yellow cable here. There we go. So I've got a female to male, and yeah, we'll just use any digital pin, it doesn't matter. I just make sure that I get a pin that is digital. And most of these pins are PWM, which is interesting. Not something I really care about in this particular project, but it's interesting that the Teensy 4.0s have all of these PWM pins. But I think what we're going to do is I'll just use pin 7 like I did before, because it's not actually being used. So we'll go ahead and connect this up to pin 7. Ooh, it's really loose. Hang on a minute. Let's get a pair of tweezers and fix that loose cable. There we go. Should be farther in. There. Should be okay. A little bit more. I just don't want this falling out. He says as it falls out. Alright. Well, I'll have to work for now. Alright, and we'll go ahead and connect it to the input number 1. So that'll go straight across from A1 to B1 here. And just kind of like slides right over that cable, and a little concerned about the integrity of data that goes across it. Just imagining a situation where where it just doesn't connect. If I didn't destroy the cable. Yeah, I'll have to fix it later. In the meantime, let me grab another yellow cable. It will have to be green. I cannot seem to find another yellow one. Why is this? That's not the right cable. There we go. There, that actually hooks in. Alright. Now I connect that up. Alright. So that's our translation. Perfect. So now we'll be able to actually control the on-off switch with this. Let me go ahead and connect up the power and ground real fast and just see if this actually, works. In fact, actually, I don't even need to do that. I'll be right back. Gonna grab a cable to program this with. Okay, let's connect this up. And this should give me the power I need. Oh, he says, grabbing the wrong cable type, USB-C. Okay, this one should work. Yeah, micro USB. My personal charging cable, but I'm sure I will find another one around here somewhere. At least it's long.
They say they talk too much. They're busy thinking about how they gonna pull me down, but they forget I'm still
Okay.
rising like skyscraper.
So we're going to
Yeah, I tried to be your pretty tall bitch.
change our platform IO code here.
Right now you're trying way too
So
hard.
instead of the UNO environment, we're actually going to, it would be our teensy environment. Let's see. Platform IO, teensy 4.0. Should be an environment for this somewhere. Put this back in place. Excellent. So this should be our teensy 4.0 environment. Platform is teensy. And the board is teensy
It's
4.0.
YouTube Music. Download the app today and get a trial of Music
And
Premium on us. Restrictions apply.
very professional. Okay. And then we'll make our default environment our teensy environment. Platform IO defaults environment. Nope, that's not it. There it is. And this will be our Teensy 4.0 environment. Alright, compile it real fast just to make sure that I'm not missing anything. Oop, I am. What am I missing? DD7 isn't a thing that exists in this one. It's a D7 then? DDD7, okay. Sure. Why not? Alright, recompile. There we go, much better. Okay. Okay, that should work, I think. Is that executing what we want? It is. Fantastic. Okay, so now we hook this up to actual power, because otherwise I end up with a different grounds, and it's a problem. So if you ever connect up like if you ever connect up LEDs or something to a power supply, and then you program your Arduino using only USB power, and you're powering these LEDs or whatever else on this power supply, but you're powering your Arduino using your computer, you'll end up with different grounds. So the term is common ground. What you want is you want your Arduino or your Teensy or whatever you're programming, you want all of your stuff to share a common ground or a common exit. Because if they don't, what'll happen before they get to AC, if they don't, what'll happen is you'll end up with weird issues where your bridge rectifiers convert the AC electricity to DC, and they're converting them at different points in time, and they're converting them at different rates. And so what will happen is you'll end up with weird things happen with your projects where your lights will like give seizure flashes, and just things won't work, and it's terrible, and nobody likes that. So be aware that you have to plug everything into the same bridge rectifier ground if you want everything to work correctly. So let's go ahead and wire this up real fast. This is our VN. Let's see. Male to female cables here. Oh, perfect. All we needed was our 5 volts from our power and our ground. Since both of these 3.3 and 5 volts actually share the same ground through this barrel connector, I can safely plug things into the grounds on both of these and not have issues with not having a common ground, because they do have a common ground right here. As long as you get to a common ground before you get back to AC or back to your bridge rectifier, that's fine. Okay, let's give this a quick shot and make sure it still works. Okay, so it looks like that this does work. This LED is blinking on and off. It looks like, for whatever reason, I'm not, disconnected. This is connected. Yeah. Looks like for whatever reason I'm not, I don't seem to be getting a strong signal back out here. Or at least a strong enough signal back out here to this guy. So I'll have to take a look at this and see what happened, what I did. But this LED is blinking on and off, and that's exactly what we want. We have our 3.3 volt signal coming from here, and then being translated through this 3.3 volt to 5 volt level shifter, and then coming back out here to the signal wire of this and turning this LED on and off. And essentially that'll, once I fix it, it will turn this on and off, and it'll supply power or not supply power to this guy. So that's exactly what we want. Looks like we've got 5 volt power. Yeah, looks like we've got everything that we need. Fantastic. So I'll go ahead and end the stream here. And yeah, hopefully you guys learned something, and we'll go ahead and finish up this project probably on another stream tomorrow or next week maybe, or I'm not sure exactly what. So we'll figure it out. But yeah, I'd like to maybe do some more SMP soldering and kind of chill with you guys maybe tomorrow, and put this on hold for now. But yeah, I'd like to finish this up on stream and, you know, kind of show different techniques. Again, this would have been a lot easier if I had just chosen the easy route and just replaced the board with this, which has both 5 volt and 3.3 volt out. But you know, where's the fun in that? So I'm gonna go ahead and call a stream here for today, and yeah, I'll see you guys tomorrow on tomorrow's stream. Should be fun. All right, enjoy.